Good afternoon, everybody. So last week, we spent our time developing the aggregate demand side of the economy. Recall that we started with our IS curve, which shows us the combinations of the real interest rate and economic output that give us equilibrium in the market for goods and services. We followed that by developing our monetary policy curve, which told us how the central bank was going to determine the interest rate, real interest rate that it would set. And then by combining the two of those, we saw that we could figure out the aggregate demand curve, the inverse relationship between inflation and economic output. And the reason that the aggregate demand curve has that inverse relationship is because higher levels of inflation lead the central bank to raise the real interest rate, raising the cost of borrowing, reducing spending, and reducing economic output. Now, as you're very well aware, if you have a demand curve and nothing else, you can't tell equilibrium anything. So we need to match our aggregate demand curve with an aggregate supply curve. And that's going to be the focus of today's lecture. We want to look at something that's called the Phillips curve, which is sort of the basis on which the aggregate supply curve is built. So the Phillips curve itself, before I go, I knew I had this piece of paper in my hand for a reason. Just want to remind you, problem set number 3, due next Tuesday, is posted on B courses under files under problem sets. So it's there if you want to look at it. Okay, back to the Phillips curve. So the Phillips curve was derived by a New Zealand economist, A.W. Phillips, who was working in the United Kingdom primarily in the 1950s. And he looked at about 150 years worth of data in the manufacturing sector in England. And when he plotted the data, what he noticed was that there was an inverse relationship between wages in manufacturing and the unemployment rate in the manufacturing industry. Other economists, knowing that wages were the primary cost of production for most business firms, generalized the Phillips curve to look at inflation and the unemployment rate. So if wages were roughly 2/3 to 3/4 of the total cost of production, whatever was happening to wages was also probably what was happening to prices. So it wasn't a real great leap. So when we talk about the Phillips curve, we're generally talking about inflation and the unemployment rate. So when Phillips graphed this, he put the wage rate, we'll put the inflation rate on the vertical axis, and the unemployment rate on the horizontal axis. And when he plotted the data, he saw something that looked like this. So this is what we now call the Phillips curve. And notice what this tells us. When the unemployment rate is low, say at U0, then we can come up to the Phillips curve, and we see that inflation will be relatively high. And when the unemployment rate is quite high, say at U1, we notice that the inflation rate is relatively low. And hopefully the intuition behind this makes a lot of sense. When the unemployment rate is very high at U1, there's a lot of slack available in the labor market. There are more people looking for jobs than there are job openings. So it's really hard for workers to negotiate for higher wages. So wages won't be rising very quickly. If wages aren't rising very quickly, then prices also won't be rising very quickly. On the other hand, if the unemployment rate is quite low, say at U0, now the labor market is very tight. There are not very many available workers for each job opening. So in that case, for a business to attract new workers, they basically have to steal them from another firm. Right? And the incentive that they provide for a worker to move firms is a higher wage. So wages should be rising more quickly. Again, if wages are 2/3 to 3/4 of the cost of production, now prices will be rising faster as well. So that's sort of the intuition behind the inverse shape of the Phillips curve. Now there's one other thing that the Phillips curve can tell us, and that is that there is a trade-off between unemployment and inflation. That is, we can, in some sense, select where we want to be on the Phillips curve. Notice that as we move back and forth on the unemployment rate, we will also be moving up or down in the inflation rate. So suppose you were a very cynical politician, and you realized that when the unemployment rate's really low, your chances of being reelected to office are really high. So you think, the way to get reelected is not to raise lots of money through PACs, but rather to get that unemployment rate down. Let's have a really low unemployment rate. But notice that there's a cost associated with that, and that's higher inflation. So you get reelected, but now you've got higher inflation. So if you have an unemployment rate that's, you think, too high, there are policies that the government can use to bring the unemployment rate down. The trade-off, of course, is that inflation will be higher. Notice we can also look at it the other way around. Suppose that you think inflation is too high. So if you think inflation is too high and you want to bring it down, the Phillips curve tells you what the consequences of that will be, higher unemployment. So the Phillips curve then gives us this menu of options that we have at various unemployment rates and inflation. Where do we want to be? So that's our original Phillips curve. Now this is another way of looking at the same sort of information, where the blue line here is the unemployment rate and the orange line is the inflation rate. And generally speaking, when we look at this, when the unemployment rate is quite low, relatively low, these kind of spots here, when the unemployment rate is relatively low, we typically see that inflation, maybe with a lag, but we would still see it, inflation would be rising. Sometimes the lag isn't very, very long, but there does seem to be somewhat of a relationship here. So this data, as well as Phillips' original motivation, seem to coincide. Now, it turns out that when Phillips did his original work, he did it with, as I mentioned, wages and unemployment. And the wages that he used were nominal wages, because that's what he had data on. So he looked at nominal wages and unemployment. But this led to the first of two big problems with this original Phillips curve analysis. The first of these problems is nominal wages is not what either workers or businesses care about. Workers care about how much their nominal wage will purchase. Right? That is, they want to know something about their real wage. What's the purchasing power of their wage? Same thing for businesses. They don't really care about the nominal wage, but rather what is the nominal wage relative to the price level. That tells them something about the real cost of hiring a worker. Right? Remember earlier we had compared the real wage with the marginal product of labor. That's what we care about. So what we need to do then is to think about real wages. Now consider this. Most of the time we bargain in terms of nominal wages. Right? We all know what our nominal wage is going to be when we have a job. It shows generally right on your paycheck, or it'll tell you what you're getting paid per hour, per month, per year, whatever it might be. So that's your nominal wage. So when there's negotiations then for wages, and you think about real wages, you also need to have some idea of what inflation will be over the time period that you're looking at. So if you negotiate wages once a year, you care about what inflation will be over the next year. If you're a labor union, for instance, and you're negotiating for higher wages over, say, the next 3 years, on that 3-year contract, now you want to know what those wages, what inflation will be over that 3-year period. If you think inflation could be really high, you want to negotiate for very high nominal wage gains so that your real wages will grow. If inflation is expected to be fairly low, then you don't need to negotiate for really high nominal wage gains in order to get the same real wage gains. Okay? So expected inflation is very important then in terms of how we can translate from nominal wages into real wages. So that's the first flaw. We need to somehow get expected inflation into our formula. A second flaw that came up in thinking about the Phillips curve was that when we talk about inflation being high or low, it would help if we had some benchmark to compare it to. What does high mean? Is a 4% unemployment rate high? 5%, 6%, 7%, 8%, 9%, 10%? Now, we might all agree in the United States 10%, 9%, 8%, 7% is a high unemployment rate. But high compared to what? Right? Likewise, what's a low unemployment rate? When we talk about high and low, we need to have some benchmark for comparing that to. The benchmark that we use is something that is known as the natural rate of unemployment. The natural rate of unemployment. U sub n. Now, the natural rate of unemployment is the unemployment rate that exists in the long run when the economy is a potential output and the labor market's in equilibrium. So remember in our production function analysis of many weeks ago, we saw that in the long run, the demand for labor, which is nothing more than the marginal product of labor from the production function, and the supply of labor would tell us what our equilibrium wage is, and therefore equilibrium employment. In equilibrium, there still, however, will be some people who will be unemployed. So when we think about long-run equilibrium, it does not mean everybody in the labor force has a job, and therefore the unemployment rate should be zero. There are several reasons why unemployment will exist even when the labor markets are in equilibrium. One of those has to do with search costs. Search costs simply tell us that looking for a job as a worker and as a business looking for the appropriate employee is not costless. It involves time and effort to find the right match between available workers and job openings. So when you start to interview for jobs as you're getting ready to graduate, chances are you're going to want to interview for more than one job, even if that very first interviewer offers you a job on the spot. Unless it's your absolutely ideal company and position to work in, chances are you're going to want to see what other alternatives are available to you. The same thing works from the employer's perspective. It is extremely rare that an employer would interview one person and decide, that's the person I need. Most of the time, they're going to say, wow, that person is really great, and now let me interview some more just to see how wonderful they actually are. All of this takes time and energy. It's the time part that means that there will be people unemployed for some period of time once they enter the labor force. Right? So we can think about people who decide, I don't like my job anymore, I'm going to quit, and then they go start looking for a job. They don't have something to go to work for right away. Right? They'll be out of work for some period of time. Recent college or high school graduates oftentimes don't have jobs upon graduation. They would be considered to be unemployed while they're looking for a job. Right? So those search costs means that there's some level of unemployment that's going to exist even when the economy is in long-run equilibrium. Whatever that is, that unemployment rate is what we refer to as the natural rate of unemployment. The natural rate of unemployment. Now, we don't have precise measures of the natural rate. Broadly considered to be somewhere between roughly 5.5% at the low end to maybe 6.1, 6.2 at the high end. So that's kind of where we are. So generally, we think about a half a percentage point range in here in terms of what we're looking at. But again, it's the unemployment rate that exists even though the labor market is in long-run equilibrium. What this means then in terms of our Phillips curve is we need to take account of what this natural rate of unemployment is. It will be deviations from this benchmark that will tell us how tight or slack the labor market actually is. Now, when we make these two adjustments, we end up with the following equation for the Phillips curve. So here we have actual inflation equals expected inflation. So remember, this expected inflation term is to move us from nominal wages to real wages. I want to bargain for real wage increases. In order to do so, I need to know what the expected inflation rate will be. And then we have this second term, which is some function of the unemployment gap, the difference between the actual and natural rate of unemployment. Now notice there is a parameter here, omega, which tells us how sensitive inflation is to that unemployment gap. And there's a minus sign here, which again also tells us that the bigger the positive gap, that is the higher actual unemployment is relative to the natural rate, the more actual inflation will fall below expected inflation. When the unemployment gap is negative, the unemployment rate is below the natural rate, then we would see upward pressure on actual inflation, over and above what we expect. So again, expected inflation is going to help us to move from nominal wages to real wages, and the natural rate of unemployment is going to give us a better measure of how much slack there is in the economy, in the labor markets, and what effect that will actually have on inflation. Do you have a question? Yes, sir. Okay, so this new formulation is sometimes referred to as the expectations augmented Phillips curve. This was derived independently by Milton Friedman at the University of Chicago and Edmund Phelps at Columbia University. They both won the Nobel Prize in economics mostly for this work, but for others as well. The only difference is they won it 20 years apart from each other. I don't know, can't explain it. Now, one of the interesting things about this expectations augmented Phillips curve is to notice that if the unemployment gap is 0, right, the actual rate is at the natural rate, then what do we see? Actual inflation will equal expected inflation. This is a relationship that's very important to us. What it tells us is that in the long run, when the labor market's in equilibrium and we're at the natural rate of unemployment, the inflation equals expected inflation. We'll come back to this time and time again over the rest of the term. Also notice there is no long-run trade-off. When, in the long run, the actual unemployment rate is equal to the natural rate of unemployment, it's not influenced by the inflation rate. So once again, the classical dichotomy holds. So one of the things that we can look at then is the long-run Phillips curve. We've already got a short-run Phillips curve, but our long-run Phillips curve is vertical. Notice that one of the things that tells us is any deviation in the unemployment rate away from the natural rate is going to cause huge changes in inflation. But changes in inflation will not cause any changes in the natural rate of unemployment. Works one way, but not in reverse. Again, no trade-off between the two. Now this diagram, very similar to the chart that I showed you just a few minutes ago. But in this case, I took the unemployment rate, the actual unemployment rate, and from that, I subtracted 5.5 as an estimate of the natural rate of unemployment. And one of the things that you'll see is, that means, by the way, that the zero line, anything negative, all these areas down here, suggests that the labor market is very tight. Right? That is that the actual unemployment rate will be less than 5.5%. So these are all the negative values. Now, if you look at what happens shortly afterwards, one of the things that you see, inflation rises. Sometimes it rises a lot, sometimes not so much. So again, what we see then is when the unemployment rate is unusually low, below the natural rate of unemployment, that we actually see inflation rising. Also notice that during this entire period of time, from the mid-1980s on, we have very few periods where the unemployment rate is below the natural rate. And so, by and large, the inflation rate, as we might expect, has been coming down on trend. It does counter-trend once we hit very, very tight labor markets. Okay, so what this shows then is that we have two different types of Phillips curve, a short-term curve and a long-term curve. With the short-term curve, there may be a trade-off between inflation and unemployment. And there's also a long-run curve in which there is no trade-off. So still, when we're thinking about operating in the short run, business fluctuations, we would anticipate this kind of trade-off between the unemployment rate and the inflation rate. But in the long run, no such trade-off exists. Another way to see that there's been no long-run trade-off is to think about what the average unemployment rate has been, say, over the last 50 years. And the average over that period of time happens to be 5.5%. Doesn't matter whether inflation rate's high or the inflation rate's low, it's 5.5%. So 5.5 seems to be about the natural rate of unemployment, no trade-off on average over the long run, only during short periods of time. In other words, the unemployment rate, as we've seen with every model that we've worked with up to this point, goes back to its long-run equilibrium levels. Now, there's one other thing that we need to add to our Phillips curve analysis, and that is there are some events that happen that have a direct effect on inflation that is completely unrelated to either the labor market or inflationary expectations. These are things that we refer to as price shocks or sometimes as supply shocks. And we will use the lowercase Greek letter rho to identify these. So a really good example here would be a sudden change in, say, crude oil prices. Right? One of the things that we know is when crude oil prices jump, the price of refined petroleum products also jumps. And since refined petroleum products are used in lots of production processes, manufacturing, as well as packaging, if you've ever tried to open something done in plastic, you know that's a petroleum product, and distribution, driving cars, trucks, trains, airplanes, the whole bit. So the prices of those items also go up, which typically leads to a direct increase in inflation. Right? It doesn't have anything to do with where the unemployment rate was at the time, and it's not a direct effect of a change in inflationary expectation. It may, however, cause later a change in inflationary